Hi again. In this video we're going to look at finding the complex conjugate to a complex number and then using that complex conjugate to divide complex numbers. Let's start off with an example. Here we have 2 plus 3i and 2 minus 3i multiplied together. The real part of the first complex number is 2, the imaginary part is 3. In the second complex number, the real part is 2 and the imaginary part is negative 3. Opposite. Let's multiply them together. All right, we know from the last video that to multiply complex numbers like this, we need to distribute or use FOIL, just like we do with binomials. So 2 times 2 is 4. 2 times 3i is minus 6i. 3i times 2 is plus 6i. And then 3i times negative 3i is negative 9i squared. Okay, let's simplify now. We have minus 6i plus 6i, so this is these will cancel. We have minus 9i squared, when we know that i squared is negative 1. And so negative 1 times a negative 1 is plus 1, so we have 4 plus 9, which is 13. All right, so notice the answer here has no imaginary part. The imaginary parts here canceled. We have the minus 6i and the plus 6i, and the I squared, of course, is negative 1, which is not a complex number. So we have 13. All right, now this is useful for dividing because we will not be able to divide by a complex number, but we can divide by a real number. So what we'll do is use the complex number, right, or use the complex conjugate to get a denominator that is real, in much the same way we do when we have a square root in the denominator. We'll rationalize. Well, here we will realize the denominator. Okay, let's talk a little bit more about complex conjugates and find a couple of those, and then we'll look at some examples of dividing. So the complex conjugate, so if you have a real number, a complex number, z equal to a plus bi, the complex conjugate of z is given by this notation. So z with a bar over it, that represents the complex conjugate, or a plus bi with a bar over it. And that's simply taking the opposite imaginary part. So for a complex number a plus bi, the complex conjugate would be a minus bi. Okay, so let's find some complex conjugates. 3 plus 2i. Real part is 3, imaginary part is plus 2, positive 2. So the conjugate would be would have the opposite imaginary part, 3 minus 2i. That's it, opposite imaginary part. Okay, go ahead and find the complex conjugate to this complex number. So real part of 1, imaginary part of negative 1. So the conjugate would take the opposite imaginary part. So we'd still have a negative 1, and then we change the sign on the I part. Okay. All right, let's look at, just in general, the product of a complex number with its conjugate. We know the answer will be real, but that real number will have a particular form that we can use to take advantage of later. Kind of simplify our work. It'll allow us to perhaps avoid multiplying out each term and then canceling. Let's check it out here. So a times a is a squared. A times minus bi is minus abi. Bi times a is plus a, bi, and there you see these two terms will add together and be 0, or opposites. And then we have minus b squared I squared. Okay, so now we know these cancel out. We've got a squared, and then I squared is negative 1, times negative 1 is plus 1, so a squared plus b squared. So taking a complex number times its conjugate will give you the real part squared plus the imaginary part squared. Right? No i's involved. This is a real number. All right, so when we multiply conjugates, we'll have a quick way to evaluate them. All right, now let's look at some examples of dividing. All right, let's keep going on dividing complex numbers using the complex conjugate. So I've just moved the a plus bi, a minus bi equals a squared plus b squared over here. That is a complex number times its conjugate is the real part squared plus the imaginary part squared. All right, so here we have a division of complex numbers. This first example, 5 plus I divided by 4 minus 2I. All right, now we'd like to write the answer as a complex number, a plus bi. You can see it's not in that form because we have this division bar. We're dividing by 4 plus 2i. All right, now to break it up into a plus bi, we need to have a denominator that is one number, one real number. All right, so to do that, we will make it a real number by multiplying by the conjugate. So we're going to take this, we're going to multiply by the conjugate of 4 minus 2i, which is 4 plus 2i. Right. Now, we can't just multiply the denominator by a number. That will change the number, the complex number that we're dealing with. But we can multiply by 1, a well-chosen one. In this case, 4 plus 2i over 4 plus 2i. All right, and so to evaluate this, we'll multiply the numerators, and then we'll multiply the denominators. We know the denominators are conjugates, so we'll get this, a squared plus b squared, real part squared plus imaginary part squared. The numerator we'll have to FOIL out. Okay, so let's do that. 5 times 4 is 20. 5 times 2i is 10i. I times 4 is 4i. And I times 2i is 2i squared. And our denominator, we have a real part of 4, imaginary part of 2, so that will be 16 plus 4. 4 squared plus 2 squared. All right, we can simplify this a little bit. We know that 2i squared is negative 2, so 20 minus 2 is 18. And then 10i plus 4i is 14i, divided by 20. All right, now we'll want to take that 20 into both the real part and the imaginary part of the number to write it in the form a plus bi. Let me do that over here. So we have 18 over 20 plus 14 over 20i. And of course, we'd like to simplify that as much as possible. So we have, let's see, common factors. It looks like they're both have factors of 2 in them. So 9/10 plus 7/10 I. So that'll be our answer to this division of complex numbers. Okay, now it's standard to put the answer in a plus bi form. That is the way we write a complex number, real part plus imaginary part times I. And so this form right here would not be acceptable. Neither this one, of course, not this one. We want to write it where we have completed the division. Okay. Let's look at the next one. I've written it down wrong. want to put a -1 there. So we can get some division there. So 2 plus 3i to the negative first power. So this is equivalent to 1 over 2 plus 3i. Okay, so from here we need to multiply by the conjugate over the conjugate to give us a denominator that is real. So why don't you go ahead and determine what the conjugate is, and then multiply the numerator and denominator by the conjugate. Okay, so what is the conjugate of 2 plus 3i? We want the opposite imaginary part, so 2 minus 3i. All right, now 1 times 2 minus 3i is just 2 minus 3i. And the denominators are the product of conjugates, complex numbers. So we have the real part squared plus imaginary part squared. So 4, and the imaginary part is 3, plus 9, or 13. So the answer will be 2/13 minus 3/13 times I. All right, let's look at the last example here. And if you want to pause the video again and try this yourself, go ahead. We want to multiply by the conjugate over the conjugate of the denominator. So 1 minus 5i over 1 minus 5i. The numerator is going to be 3i minus 15i squared. And then the denominator is the product of complex conjugates. So we have the real part is 1, 1 squared is 1. Imaginary part is 5, so plus 5 squared is 25. We know I squared is -1, so that's really plus 15. So we have 15 plus 3i over 26. And then we can write that as 15 over 26 plus 3 over 26i.